Thank you very much for coming along, and welcome to session 6AJ. So we have a performance and capacity presentation. As you've probably been to some other sessions, we really do welcome the feedback on these, and there'll be a link at the end, and you can see in the slides for the session. There'll be a reminder about the other activities, but other than that, general rules apply. We're keen to get all your questions in the chat, and at the end we'll go through them. And I think Scott potentially has a strategy for kind of dealing with those. But other than that, I'm sure Scott would like to be talking, not me. So I definitely hand you over. Thanks very much, Scott.
All righty, thank you very much, Herb. And thank you everybody for joining me today. So yes, I'm coming to you from across the pond in central Ohio here in the US. So if I don't sound quite like what you were expecting, that's probably because I'm far away, not because I have a different accent or anything, right? So anyways, let's get to it here. Hopefully you've heard about the GSE UK's charity raffle. And if you somehow haven't heard about that by now, here's the information about that. Here's the obligatory contact copyright and trademark slide. This is the abstract, and I presume you have all read the abstract, and that's why you're here. Hence, I am not going to read it to you at this moment. I will say some of you may not be familiar with us at Enterprise Performance Strategies, because again, we do get over to the GSE UK conference fairly regularly. It is a little bit harder for us to get to just because it's across the pond and all. But at EPS, we do zOS performance. So we have a tool called Pivotor, which is our reporting and analysis software and service, which really helps you understand your mainframe performance. We also do education and instruction. So we do zOS performance workshops. I have a slide on that next. We do some limited amount of consulting as well. This consulting that we typically do these days is typically focused on, what we call our war room engagements, where we'll come in for a couple of days, although these days we're doing it virtually via Zoom, and we'll sit down with your team and go through whatever's causing you angst today in terms of your zOS performance. And then, of course, we like to present at conferences and participate in the online forums and all that sort of stuff. This is the slide about our zOS performance workshops. The neat thing about our education is that you'll be analyzing your own data. So part of the process is you send us data, we process the data, we make the reports available to you. So you're not just looking at sample data when you're going through our performance workshops. And Peter, my colleague and friend Peter Enrico, he does the WLM performance and reevaluating goals, and he also does the parallel sysplex one. I do the essential zOS performance tuning one. Peter's parallel sysplex and zOS performance is coming up here shortly. So if you're interested in that, that is via Zoom, as they all have been these past couple of years. So if you're interested in that, let us know. We also do free monthly zOS educational webinars, or somewhat monthly. Seems like we do them every couple of weeks for several months, and then we take a couple of months off. So if you aren't signed up for those, certainly sign up for those. Again, send me an email or something. I'll set you in touch with the right person to get you on that mailing list. And this is just a slide saying, hey, the graphs you're going to see here, the zOS performance graphs all come from our tool. And if you don't see them in your tool, then perhaps you should talk to us, and we'll be happy to either make such available to you. You can certainly become a subscriber, but there's certainly also a free Pivotor offering, a free tier available as well. And of course, we're happy to process a day's worth of data and have an hour-and-a-half phone call with you just to go over some highlights of your data and so forth. So. Now, let's get back to what we really are here for, which is what is SRB and what types of boosts are available? When will those boosts be triggered? Everybody probably wants to know, will this impact my software bill? And how will the LPARs be impacted? And of course, the last thing down here is perhaps what really got me interested most distinctly, which is how is the SMF performance data impacted? Because that's a big part of what we do, right? Is we process people's performance data. And if now the performance data is going to be different or going to be somehow skewed, I need to understand that, right? So that's part of this as well. And then, of course, at the end, I'll have some summary and recommendations. Now, when we say SRB for System Recovery Boost, I always immediately think solid rocket booster, right? These things on the side of the space shuttle, which helped get the space shuttle to orbit. So that's why you'll see the space shuttle things here. And because I just love space, right? So we're going to start off with what is SRB and what types of boosts are available. So System Recovery Boost's overall goal is to provide additional capacity and performance to better recover from certain planned or unplanned events. Basically, the idea is that SRB should help you shut down faster, start up faster, do faster DR site switches, do faster sysplex recovery, basically reduce the amount of time that your business is impacted by, again, either those planned activity or unplanned activities. Now, this does require a Z15 machine because IBM would love you to have a new Z15 machine. The great news is, though, there's no additional charge for the basic System Recovery Boost. Now, there is a potential extra cost item that we'll discuss in just a moment, but most customers are not going to need that or want that extra cost item. So the types of boosts, there are two different types of boosts that we're talking about here, and both kind of break the rules for what has been the standard operating procedure for a couple of decades, right? So the first type of boost is called speed boost. And basically what speed boost does is it takes your subcapacity engines, okay, those engines that you have, if you're on a machine that's not a 7XX machine or you're not a ZXX machine, meaning you're not one of the machine capacity settings that have access to full speed general purpose engines. If you're using those, what we sometimes call kneecapped or subcapacity engines, those engines that are restricted by microcode to running less than full speed, well, now all of a sudden they will run as if they are full speed engines. Those microcode limits will be released for the LPARs that are being boosted, and all of a sudden those you will enjoy the full capacity of a full speed engine. Okay, now the important thing to note here is that this is only happening for the boosted LPARs. It's not like LPAR A gets boosted and then all the LPARs on the machine enjoy full speed engines. No, just A enjoys the full speed engines. So again, the way those kneecapping, those subcapacity engines work is not via the clock speed of the chip or anything like that. It's via microcode limitations, right? It's not exactly this, but you could almost think of it as the microcode inserting a stream of no-ops into your instruction stream to essentially waste time, right? So that you're not getting as much work done out of the processor. Since that can happen on an LPAR by LPAR basis, they can easily then not do it for an LPAR, right? Which is what they're doing for the boosted LPARs. The other type of boost is what's called zip boost. And a zip boost basically says the zips can run work that would not otherwise be eligible to run on zips. That is, any work may be dispatched on the zips. Basically, the zips get treated just like the general purpose engines in terms of dispatching any type of work. The other interesting point here too is that if you have an LPAR that has reserved zips, that means zips that are defined to the LPAR, logical zips are defined to the LPARs, but they're not online to the LPAR, those reserved zips will be brought online automatically when the LPAR gets boosted. Now, also note that your zips always run at full speed, right? So basically what this means is with the combination of speed boost and zip boost, right, you suddenly have, for that work that was general purpose engine only work, now they suddenly have access to far more capacity potentially, right, than they did before, because now that unit of work that could only run on, say, a subcap general purpose engine Now it could run on a full speed general purpose engine, or it could run on a full speed zip, because zips are always full speed, right? So this potentially is a great benefit to that general purpose only work. Now, what if you need more zips, or you want more zips for your zip boost? Well, that's where we come to the extra cost item, right? So if you have a need to have more zips available during these boost periods, well, you can pay IBM some money and then you can get that, right? So this is a subscription feature that allows for activation of what would otherwise be uncharacterized physical processors. You can characterize those as zips and bring them online during boost periods, okay? So you can add up to 20 zips. It does allow for violating the 2-to-1 zip to GCP ratio. It's basically handled like a capacity upgrade record. The boost upgrade record is activated in 6-hour increments, but the boosts are still limited to their normal timeframes. And we'll talk about what those timeframes are here in a little bit. You know, my expectation is this is primarily expected to be useful for the large full speed systems, right? So the 7XX systems that may have many LPARs on them and may be IPLing many of those LPARs in short succession. And maybe in those cases, having additional zip capacity to help with those boost periods may be useful and may be cost justified. In most other cases, I don't think it's probably going to be. So how big of a speed boost are we potentially talking about here, right? So these two charts here, they're the same basic charts. One is for the smaller machines, one's for the larger machines. The basic idea of this chart is to show you, depending on your subcapacity level, how much larger is a full capacity engine? How much more work are you going to get done per unit of time on those larger engines? So, and while I did these for an M0 for a 3-way and an 8-way, it doesn't really matter about what N-way you are. If you are, for example, an M08 or an M03, sorry, you wouldn't be an M08, obviously. Say you were an M06 or an M04, it doesn't really matter. If you're on an M level of a subcapacity engine and you go into speed boost, well, basically your general purpose engines are now going to be running 4.1 times faster, okay? So it doesn't really matter. Again, the exact number of CPs doesn't matter here. It's really that first character that indicates that. You can see that if you're stuck with a very slow subcapacity machine, so you're on an A-level machine, right? So you're on a very tiny A03, all of a sudden you go into speed boost and you get over 17, almost 18 times more capacity than you normally had. That's a pretty huge deal, isn't it? Even on the larger machines over here, right? Even if you're on a 600 series machine, right? Now you have a 1.7x multiplier, right? So now your general purpose engines gets 1.7 times more work done per unit of time. That's still pretty good, right? So next major question, when will boosts be triggered? When do we actually light off that a solid rocket booster? So those are called boost classes, okay? And basically the boost classes are triggering events. And there's basically 3 different boost classes today. We have shutdown, IPL, and then recovery process boost, okay? Now, so this table here kind of tries to summarize this. The shutdowns and the IPLs happen on the single system where the shutdown or the IPL is occurring. You can see the duration of those boosts here. So the shutdown boost lasts for 30 minutes on the system that is being shut down. The IPL lasts for 60 minutes on the system that's being IPL. And recovery process, though, is a little bit different because the recovery process boost talks about a situation where, for example, maybe you brought a system out of the sysplex, maybe there was a CF failure, maybe you're going through a hyper swap, maybe you're building a CF structure. So there's multiple reasons. Basically, something's happening within the plex that requires some sort of recovery processing, okay? And so the point here is that the recovery process boosts actually happen across multiple systems potentially. For example, if you have a CF data sharing member recovery that's triggered by disconnection from the lock structure while the locks are held, the recovery process boost happens on the surviving members, right, that had an interest in that lock structure, right? So those surviving members will get that recovery process boost. And we'll see an example of that in just a moment if I don't sneeze first. And if I do, I apologize in advance. The other point here too is that WLM is involved in these boost periods as well. Okay, so when you begin a shutdown process and you enable shutdown boost, WLM is smart enough to say, oh, this system is coming down. We're going to route work away from the boosted system because that system's about to go away, right? So that kind of makes sense, right? Now, in contrast, when you're IPLing, WLM starts routing work to the boosted system, which also makes sense, right? Because now the system is coming up. I'm trying to get work done again. I'm trying to get potentially caught back up after I just had to do an IPL. Well, wouldn't it be great to route more of my work to the system that is running faster, right? It's running unnaturally fast. We just said, by multiple times perhaps. So why don't I route work there? Now, there's a bunch of controls you can enforce over that too, because it doesn't just stop routing work there at the end. It kind of tails it off, and there's some controls you have in ParmLib for that. We're not really going to get into those details here, though. And then finally, the recovery process boost. There's no change in the WLM routing because the recovery process boost really only lasts for a couple of minutes, okay? The stated answer is they're less than 5 minutes each, but what I've seen is they can be about 2 minutes, and actually some of these recovery process boost scenarios can overlap with each other, so they can extend the boost period and so forth. But regardless, they're going to be a few minutes. So let's talk about these in a little more detail. So first is IPL boost, okay? An IPL boost is enabled by default, but you can control it in ParmLib in IEA there's a new option, boost. The default is boost equals system. The other options are zip, speed, or none. Basically, system says use both types of boosts if they're available, whereas zip or speed says limit my type of boost that I'm using to just this one form of boost, okay? Why would you want to do that? Well, we'll talk a little bit about that later when we talk about what are the impacts on the other LPARs, right? So if you are having interesting, let's say, inter-LPAR interactions, maybe there's a reason that you don't want to have zip boost enabled, or I guess maybe you don't want speed boost enabled. So maybe you'd only set it to zip or you'd only set it to speed. But in the vast majority of the cases, I think you'll probably just want to leave it as system, which really, as I said, is both. Use both boosts if available. The IPL boost, as I said, lasts for 60 minutes. Here's an example from an IPL from one of my customers. The hour, basically starts when WLM comes up and zip boost is possibly enabled. You'll see here that the speed boost actually started just a little bit earlier. Then zip boost started here at 13:33:08, and that's when we got the WLM message about boost being activated, and exactly 1 hour later at 14:33:08, the boost ended, okay? And of course, during this time period, WLM reports the boosted capacity, and this may result in more than normal work being routed to that boosted LPAR right after IPL. In contrast, shutdown boost is initiated by you running proc IEA SDBS, right? So I'm guessing that means shutdown boost. Obviously, you need to change your procedures to invoke this and change your shutdown procedures to invoke this proc, right? Now, once you've enabled this, once you've run this proc, you can't do this shutdown boost again until the LPAR is IPL'd. So don't think this is a free lunch. Oh, I'll just go run this proc 2 or 3 times a day because I want to boost myself. No, you get one boost, one shutdown boost per IPL. And so the question kind of becomes, when do you enable that, right? Because the shutdown boost does last for only 30 minutes. And at that point, WLM starts to avoid routing work to the LPAR. And at the end of that 30 minutes, you lose the boost advantage. But depending on what kind of work is running on your system and how long it takes you to shut down, depending on when you're IPLing things and so forth, it might actually make sense to initiate this more than, say, right before I'm going to start killing all the all the address spaces, right? Maybe it makes sense to do this, an hour before you intend to have the system down, just so you can get whatever batch work happens to be sitting there, you can get that out of the system easier, so that when the time comes, you're all ready to do the shutdown. It really depends on your system. And so there's just a little bit of thought you might want to give to that. I'm not saying you need to go do any major analysis on this. You know your systems, you know the situation, so probably more or less intuitively of when it would make sense to do that. Obviously, you don't want to run it too far in advance. It doesn't make any sense to run it 6 hours in advance, because it's only going to last for a half an hour. But I could definitely see cases where you might run it, an hour before the target shut down or something like that. Now, the recovery process boost class is the most interesting one. Again, this one is automatically initiated by the system. Again, it respects the boost parameter in IASYS, and it won't be initiated if the LPAR is in either an IPL or a shutdown boost. Again, these are short duration process. These are short duration boosts, and the LPARs have a maximum of 30 minutes of recovery process boost within a given 24-hour period. And the examples I've seen, the sysplex partitioning boost seems to be pretty much exactly 2 minutes. So I'm not sure exactly where all the different ones lie in terms of exactly how long they may take. But again, they're very short duration. And of course, as I mentioned earlier, multiple reasons can overlap. Now, interestingly here, the zip boost is limited to bringing online 2 reserved zips. Okay, so if you have an LPAR that has 6 reserved zips and you go through an IPL boost, all 6 of those reserved zips are going to come online. But if you're in a recovery process boost, only 2 of those zips are going to come online. So what does that look like? Well, here again is a little bit of an example. Here they've varied sysc out of the sysplex. And pretty much as soon as they did that, within 1 second, you can see here that the recovery process speed boost was activated, right? And it was activated on sys-A and sys-B because they're the surviving members within the sysplex, right? And then you can see here that they initially were activated with the CF data sharing member recovery, probably because the sysc was disconnecting from the lock structure, right? And then you can see here 20 seconds or so later, the recovery process boost was extended due to sysplex partitioning. And then 2 minutes after that, the boost ended, right? So that's kind of what the messages and the logs look like. The important thing to note here is that, sysc was the one that was coming down. Sys-A and B were the ones that were boosted. Now, sysc may have been boosted himself, right? Because they may have initiated a shutdown boost for sysc before they started bringing him down. But once they got to this point, that's when sys-A and sys-B were basically boosted to help with those cleanup activities. So now you may be thinking, oh my gosh, I'm going to use more CPU. Will this impact my software build, right? Which is a very nice, good concern to have. And by design, the idea of the IBM statement is this should have no impact on your software build. However, if you think about it, the MSU rating of the machine is not changed during the boost periods, okay? But you get more work done. So for example, if you're running on an N04, and your boosted LPARs consume 100% of 2 zips, or 100% of 2 general purpose engines and 100% of 1 zip, and your N04 is rated at 214 MSUs, 2 engines is half of that capacity because you have 4 general purpose engines. So basically, you consumed 107 MSUs worth of capacity from a software pricing perspective, but while they were boosted, they were doing 395 MSUs worth of work. So if you think about it, you're getting more work done for the same MSU rating, that kind of means that probably your software bill, if it's going to be impacted at all, is probably going to be impacted to the good, right? So this is almost certainly a good thing. Now, theoretically speaking, if you're boosting work and getting more work done, that may shift when things get done in terms of time. So it might impact your timing of your peaks. Probably doesn't matter really. Most people aren't IPLing in or near their peaks, so it probably doesn't matter. For TFP customers, all of your CPU time counts as always. So again, while you will get charged for the CPU time you consumed, you're getting more work done per unit of time. So that should be goodness. I do point out here that the 70s and 89s do contain boost indicators. So theoretically, somebody could be deciding to change rules on you, but I don't think that's the case today. Alrighty, that's kind of all the basics. The more interesting thing is what LPARs will be impacted and how. And if anybody can identify the racetrack where these were taken, you get bonus points. Of course, the points don't matter, but you know. So LPARs being boosted. So the LPARs are being boosted. It seems really obvious. They're going to get more work done, right? So this just is a goodness. But they may need some changes to their definitions to get more work done. Maybe you might want to define more reserved zips to the LPAR to be brought online during boost period. So maybe that LPAR normally has 2 zips online to it, but you actually have 4 zips on the machine. Well, you might want to define the other 2 zips as reserve zips, i.e. they're offline to the LPAR, but they can be brought online during a boost period. Now, the other point here is that you may need to add zip weight then to be able to access those newly online zips, especially if you want to be able to access that or in preference to other LPARs on the machine. And we'll talk about those other LPARs in just a moment. The other point here is somewhat esoteric, but because you have an increased zip usage potentially, right? Because now your zips are running both zip eligible and non-zip eligible work, that could mean that some zip eligible work might cross over to the general purpose engines, okay? Now, if you have set up your service classes, you can do this on both a service class and a system basis. We don't recommend today doing it system-wide, but on a service class by service class basis. So if you have service classes with honor priority equals no, that work is generally prevented from crossing over. Okay, so that in other words, that stays on the zip. So you may want to consider changing from honor priority equals no during an IPL boost, okay? Because that work now may be artificially limited to those zip engines, right? Because you said, don't let this cross over to the general purpose engines. But during that boost period, those zips got much busier than usual. So now that work that is zip eligible and is prevented from honor priority from crossing over to the general purpose engines may in fact be more delayed because of that honor priority versus where it would be in a non-boosted period. So let me just again be very clear here that I'm not talking about enabling honor priority equals no during crossover or during boost periods. I'm talking about potentially setting honor priority back to yes or removing honor priority equals no during those boost periods, okay? In many cases, this is probably not a concern. And especially for the recovery process boost where we're just talking about a couple of minutes. And during the shutdown boost is probably not a concern because you're routing work away from those LPARs anyways. But during the IPL boost, that's where it's more likely to be a concern. And it just depends on, again, it depends on the exact situation, right? But it's something to consider anyways. The other couple of points here is that boosted LPARs, their overachieving work won't be eligible to help discretionary work. That's a WLM statement. Normally, if you have overachieving workloads, certain overachieving service classes may donate to help discretionary work. During boost periods, though, that doesn't happen because the idea is, hey, we want to get real work done here as quickly as possible. Discretionary work, while it's probably real work, may not be the most important thing to help really get done as quickly as possible, right? And And then finally, the point here is that new SMF interval is started when boost starts and ends, and I have a caveat about that at the end. Now, the more interesting point is perhaps what happens to the LPARs that are not being boosted, right? And the answer here is that these LPARs could, maybe, possibly, be negatively impacted. And I do want to stress, maybe, possibly, and could, right? I'm not saying this is a problem. I'm just saying that there are things to think about. So the first one here is really kind of a theoretical one, and that's the CPU cache effectiveness, right? So if you think about it, the boosted LPARs, while they're running, they're accessing more data, they're getting more work done. So that's going to have a larger impact on the processor caches versus their normal operating process, right? So those speed boosted LPARs are doing more work. The zip boosted LPARs may be driving more activity to the zips. Zip caps are ignored during boost periods. So theoretically, at least, they're driving more work through the CPU caches, and that may have a minor impact on other LPARs. In practice, and all the data I've looked at, I've not seen this evident anywhere, but it's theoretically possible, so I mention it here. The other point here is that the higher physical zip utilization may impact non-boosted LPAR's ability to get work dispatched on those zips. Okay, this I think is a much more significant one, because here what you're looking at is, steady state. None of the LPARs are really dominating the zips, and all of a sudden we have a zip boosted LPAR, and that LPAR could be driving a whole lot more work to those zips, right? And because of that, there may be less zip capacity available. And again, this is all weight enforced as well. So it depends on the weights of the LPARs they're being boosted versus not being boosted. And so the potential here is that you could see more crossover on those non-boosted LPARs. The other point here is that you may need to change the relative weights, the relative zip weights of the LPARs during those boost periods, especially if you're trying to protect unboosted LPARs. Okay. This is definitely something that I think bears some investigation and some thought, depending on how much thought you have put into your zip weights already. The other point is that resource group caps with a sysplex scope don't count work running on the boosted LPARs. Okay, so if you have work that you have a resource group cap in WLM set for, and that resource group cap is a sysplex scope, normally WLM will cap that work based on the utilization across the entire sysplex, but boosted LPARs don't count towards that. So it's possible then you could see additional work running on those unboosted LPARs in those capped service classes. Now, conversely, if the boosted systems, consume less general purpose capacity, that might help non-boosted systems in terms of the general purpose capacity available to those LPARs, right? So while I spent most of the page here talking about, bad things that could be negative, right? Bad things that could be negative. I talked about things that could be negative. There is a possibility this could be actually very good for those non-boosted LPARs as well. Okay, again, it depends on the situation. The reason I mention these things is that so you can go back and look at how your systems are performing, and you think about these things as you're going down this process. So I have a case study here from one of my customers. It was very nice to share their system logs primarily with me. We do their performance reporting for them, so I see their data every day, of course, but their system logs we don't normally see, of course, but they were very nice to share these logs with me for the purposes of this example. They have a small sysplex here that has 3 systems in it. Sys A is prod, Sys B is dev test, and Sys C is the sysprog test system. And the sysprog test system, or Sys C, is what is going to be IPL'd here. These are all part of the same sysplex, which is not uncommon for smaller sites. They're running on a Z15504, so they'll get about 2.6x speed boost. They have 1 reserve zip on Sys C. And of course, because it's a sysprog test system, there's not really much running on Sys C. So from that perspective, it's somewhat uninteresting, but from the other side of that coin, it does make it easier to see the boost impacts on the system background, i.e. there's not a lot of variation in the system background activity on that system because it's always just sitting there mostly doing its idle work, right? So this is kind of the timeline that you can see here. Again, these times probably look somewhat familiar to you. They did activate the shutdown boost here on sysc about 15, 17 or so minutes, I guess, before sysc finally came down. Actually, they varied it out, I guess, at 13:29 here. And we see when recovery boost started for those things, and then we see the IPL boost once sysc comes back up. So what does that look like graphically? Well, sysc on these charts is this purple one here. So again, we see sysc normally is a very small amount of capacity on this machine. The machine, at least on this particular day that they were doing this test, was generally fairly unbusy, right? Which is a whole separate thing. I can talk about how this is not necessarily a bad thing, but a good thing that your systems are not running 90% busy. But having said that, we're looking for this purple start here, right? And we see here where basically things went away, and we see some weird stacking issues. And the weird stacking issues is because we have weird short intervals, right? Because of the system starting and stopping their boost periods here. Now, what we do see is that right after the IPL here, it does look like sysc's general purpose utilization did go up for one 15-minute interval here. These individual bars are 15-minute intervals, but then it almost looks like it went down, right? And if we zoom in and look at just sysc, we can actually see that better here, right? We can see how sysc had this brief spike probably when they initiated their shutdown boost. Then activity fell off on sysc as things drained off from sysc. Right after the IPL, there was right at the start of the IPL, there's of course a big jump in consumption. Big being relative because we're talking about single-digit percentages of the machine, of course. But then after that, we see that the general purpose utilization of the LPAR is lower than their normal steady state general purpose engine consumption until the boost comes off, right? This chart just shows us that, hey, we brought online an extra zip during that period. This is a look at the zip consumption on the machine around this time period. And again, what we see here is that basically sysc in purple doesn't show any zip consumption except for during the boost periods. And again, if we zoom into sysc, we can see that much more clearly here, where there's essentially no zip activity. There's very, very tiny amount of zip activity on a normal basis on sysc, except for when they're boosted, when there's, relatively speaking, a whole lot more, right? Now, the 15-minute intervals are interesting, but I'm always fascinated by looking at it on a finer detail. And here we're looking at it on a 2-second by 2-second basis. And this is the entire KEK utilization. This happens to be for zip is what I'm showing here. You can see again the zip activity on the entire KEK. And this is for a much smaller time frame because we're looking at 2-second intervals now. We can see that when the recovery boost started, yes, the utilization on the KEK for the zips suddenly went up significantly compared to its background sort of level of utilization, right? And then after that recovery boost ended, we can see the utilization on the zips pretty much returned to normal. Let's talk about weights a little bit. So boost happens on a per LPAR basis, and Prism still dispatches the physical CPs to LPARs as normal. So speed boosted LPARs are just getting more work done per their dispatch interval. So absent weight changes, those zip boosted LPARs with low weights may end up using low pool zips, right? And they might not be able to access that capacity if the LPARs are busy. On the other hand, other LPARs that are using more than their zip weight may suddenly be limited if they're borrowing weight from the boosted LPARs, and now all of a sudden the boosted LPARs want their full weight, right? So what am I talking about here? Well, this is our example with sysc, right? So here with sysc, and in this case, sysc is this green line here. This particular chart shows you the percent of the weight of the LPAR that the LPAR is actually consuming. So these LPARs immediately before and after the boost periods are not consuming their full zip weight, right? And in fact, sysc never even gets to the point of consuming its full zip weight. So there's really no issue here in this particular example. This, however, might be a different story. So this is a completely different system. Here we see sys1 is regularly consuming during this period here. I don't know what that line is, 117% of its zip weight, right? What that means is that if these other two LPARs suddenly demanded their weight, perhaps because they went into a boost period, all of a sudden this capacity, this amount of capacity that is above sys1's weight that sys1 is enjoying today would be suddenly restricted, and sys1 would now be limited to just 100% of his weight. If there was sufficient demand from these LPARs down here, which there may suddenly be in a zip boost situation, right? So the point here is that if you have LPARs that are regularly consuming more than their weights like this, that's something to consider if you have perhaps a different LPAR that's consuming less than its weight, and so it's allowing this LPAR to borrow from this one, and all of a sudden you do an IPL of this that could be bad for this, right? Now, that's probably not going to happen between production LPARs and a normal basis and all that, but imagine, for, if you will, maybe this is a dev test LPAR, and dev test LPARs, hey, we need to do an IPL at noon because the development team needs blah, whatever that is, right? And so you decide to IPL at noon, and all of a sudden this development LPAR is taking this weight away that the production LPAR was borrowing from development. So again, something to be aware of. This is just the hyper dispatch pooling coming online. And this shows, showing that you had a low pool zip, and our example was how that was handled. And the low pool zip was unparked for the entire intervals. In this case, sysc enjoyed the benefits of both the zip and the speed boost without impacting the other LPARs. The overall system, both for general purpose engine and zips, were low, so there really wasn't any significant potential for conflict. And sysc uses relatively low CPU, so the increased zip utilization was really immaterial as well. Now, what I think is more important to point out here is that during the boost period, sysc consumed less of the general purpose engine capacity of the machine, right? So again, that could be a benefit to the unboosted LPARs. Again, in this particular example, we're talking about very small numbers, so not a significant benefit, but still a small benefit, right? However, it consumed more of the machine's zip capacity. This is partially due to the fact that, this is just a sysprog test LPAR, but I've looked at several examples from real customers, and they almost all look like this. About 90% of them tended to look like this, where the boosted LPAR consumed less GCP capacity than usual and consumed more zip capacity than usual. But most of that reasoning, I think, is because mostly the IPLs are scheduled at low utilization times. It'll be more interesting to see the emergency IPL. Now, this is an interesting chart that I put together because I was curious for my customers that are going through these boosts. Well, how much more capacity are they really getting, right? And so this chart tries to identify what was the extra capacity that they could have potentially used during these boost periods. Not that they used this much capacity, but they could have used, okay? This report was somewhat tricky because I was actually taking into account how busy the other LPARs were and the relative weights of the system. But in this particular case, what we see is that sysc during his boost periods basically had access to 5 times the amount of capacity as he normally would have for general purpose engine work. And you can see that's pretty evenly split in this case between the speed boost and the zip boost. In contrast, sys-A, this is the larger LPAR in a different day, and what we see here is its boost ratio was lower, and that's because it had more of the general purpose engines online, so the zip capacity was less of a relative increase in the capacity. But even here, it was over 3.5 times his normal amount of capacity. So some things that can limit SRB's effectiveness. Obviously, if you have full speed general purpose engines, you aren't going to get zip, you aren't going to get speed boost. If you have busy zips, you might not get as much capacity available to you. If you have a single physical zip shared among several LPARs, well then Prism is still going to move that zip around to the different LPARs. And so that's going to limit the amount of time the boosted LPAR can get access to it. And of course, if the LPAR doesn't have access to any zips, then it's not going to have access to zip boost, right? So this is my opinion down here in the 2020s. Almost every machine, I believe, really should have at least two zips available to it, two physical zips on the machine. And that's a philosophical discussion that we don't have time for today, but yeah. So this is an example here where we had a small dev test monoplex on a 711, so full speed engines with a single physical zip available. And what we see here is there was no real significant decrease in the general purpose utilization during the IPL boost, okay? But the zip boost, there was an increase in zip utilization, okay? And in this particular case, this is still a good story, right? So you still got more work done. There wasn't a significant decrease in the general purpose consumption, but there was still more work done by just increasing the amount of data or the amount of work done on the zips. I said data because the next step up here is how is the SMF data affected? And as usual in this presentation, I'm running a little bit behind. So I'm not going to explain all of these numbers in grave detail. Really what I'm trying to do here is trying to equate, this is our physical capacity of the machine that the LPAR is consuming, and we can convert that physical capacity of the machine to an APPL percent, basically a percent of one engine, okay? And if we do that conversion, you can see the numbers that we see here. So if the physical machine busy for sys-C was this, right, we would expect to see more or less those APPL percent numbers show up in the SMF72 records for the individual workloads, right? But that's not what we see, right? So here, this is actually pretty close, but after that initial interval here, we expect to see an APPL percent of half a zip or half a percent of a zip engine, and instead we see 0.09, right? So why is that? And why do we have 0 reported zip usage here when if we go back here, we see there definitely was zip usage, but we don't see that in the SMF72 records. Here, this shows that a significant portion of the CPU utilization from the 72s shows up in sys-STC and sys-DEM, but they didn't show up as significant users over here, right? There's a little bit of sys-STC down here in blue, but that blue is not like what you see here. So what's up with the ratios there, right? And then finally here from the SMF30 records are the sys-DEM address spaces and their reported GCP utilization, right? And so we see that, hey, the majority of this was master. We see some other address spaces here, right? Now, this report shows those top system address spaces and shows the reported general purpose CPU time and the zip CPU time. Okay, so the general purpose CPU time is in the dark blue, the zip is in the light blue, the general purpose dark orange, light orange. And if you're paying attention, you'll notice there's no light colors here, right? All of the time is showing up in the general purpose time. There's none showing up in the zip buckets in the SMF30 records. So what does that mean for the CPU accounting? Generally, across the record types with speed boost, what you will see is that service units per second numbers increase, okay? In other words, that's the real value. The service units per second are increasing because you're effectively running on a faster engine, and that shows up. The normalization values in the records also changes to reflect that the zips are the same speed as the CPs, but the MSU rating of the machine does not change, okay? In the SMF70s, the dispatch times are unaffected and report the true physical usage of the machine because you're running more work on the zip. That shows up in the 70s as the zips consuming more CPU on the LPAR level, But at the address space and at the service class and report class level in the 30s and the 72s, the GP only work still records all of that time to the general purpose buckets, not to the zip CPU buckets, okay? Also note that if you have SMT enabled, then the general purpose engine work running on a zip and SMT is recorded as MT1 equivalent time. If you don't understand MT1 equivalent time, and nobody does, but if you don't understand the concept at all, then go look at my SMT presentations about that. And then for subcapacity machines, CPU times will be lower than for non-boosted periods. Now, because of this disconnect between the 70s and 72s, basically our friend, the capture ratio is no longer applicable, right? So the capture ratio now goes above 100% on the general purpose engine side because all of that time that was captured in the 72s did not show up in the 70s in the CPU bucket, right? And conversely, if you look at the zips, it goes the opposite way. Now, if you're like IBM and you're doing capture ratios on the combination of zips and GPs, then the impact should be not as severe. But personally, I don't really believe in combining that for the capture ratio for, again, philosophical reasons we can discuss some other day. So my parting thoughts here. So SRB, the good. Overall, this is goodness. You get faster shutdown, you get faster startup, faster recovery. Your subcapacity system sees more benefits in full cap machines, which I think is great. This is really like a bigger benefit to the smaller shops, which I think is great, because a lot of times we see benefits that come to the larger shops and they're somewhat limited for the smaller shops. This is kind of the opposite. It's not hard to come up with real world scenarios where a boosted LPAR might have access to 5 to 10 times the capacity for normal general purpose work. There's no additional cost. The simple scenarios where the IPLs happen at low utilization times will see benefit, while I'd be very surprised if you see any negative concerns during those time periods. And despite the goal of no software cost impact, it seems like the real impact is possibly, maybe, potentially slightly reducing your costs. Now, the bad news is you do have to update your shutdown procedures to invoke the shutdown boost. Your LPAR weights may require attention to make sure they're appropriate during those boost periods. And of course, the boosted LPARs in theory might impact cache efficiency, but in practice, I haven't seen that. So we had the good, the bad. What about the ugly? Well, the ugly is the recorded CPU times during boost periods is confusing to misleading because of what we said about them being recorded differently in the SMF 70s versus the 72s. More interestingly is that the SMF 30 intervals could cross boost and non-boost intervals. Now, this actually turns out, so this is only happens if you are not synchronizing your intervals. Okay, so if your SMF 30 intervals are not synced, then basically you don't get a new SMF 30 record when these boost periods start and stop. If you are syncing your intervals, in other words, you have SMF sync here, then the good news is that you get new SMF 30 interval records, so they're not crossing those boost and unboost periods, but you still have an issue potentially with the full end of job records and so forth. You know, the 2-minute boost periods could be useful in some situations, but if you're doing performance tests, watch out for these, because now all of a sudden for 2 minutes or 3 minutes or whatever it was during the middle of your performance test, your processors ran completely different than what you were expecting, right? So if you're doing performance testing, you have to watch out for this. And of course, coming off from the boost could be a bit of a letdown. So here's my recommended to-do list. During shutdown, add your call to IEA-SYS, IEA-SDBS to start that shutdown boost. If you are using preserved CPU in IEA-SYS XX, then you probably want to stop the boost before your final shutdown. Go take a look at the details on that later. You might want to add reserved zips as appropriate to LPARs. Verify your zip weights are appropriate during your boost periods. And of course, understand when recovery boosts happen. Now, I'm not recommending this personally because I'm not saying you should do this, but you know, if you have a small subcapacity machine that gets significant CPU boost and you have some free zip capacity as well, and you have a significant CPU limited month-end workload, there might be an interesting thought experiment about, well, what if I IPL'd immediately before the month-end processing starts? And that LPAR now maybe gets 5 or 6 or 7 hours worth of work done within 1 hour. I'm not saying that you should do that, but I'm guessing somebody is going to try it someplace. I also don't know if there's IBM T's and C's to prevent this sort of thing from happening. I haven't heard of that being the case. I don't think IBM is restricting you on when you can IPL. I mean, you reboot your Windows machine periodically and make it happier. Why not IPL your system to make it happier, right? So again, I'm not recommending that necessarily, but I could see where probably somebody sometime is eventually going to try that. So this is the end of my session. Please submit your session feedback. I do appreciate that. And of course, the GSE UK would love you to become a member if you're not already. Hopefully you already are. And thank you. And I've seen there's things coming on over here in terms of questions. I'll see if I can take a quick look in the couple of minutes we have left here. Is recovery process zip boosting limited to just adding 2 offline zips, or does it let them run any work during the boost? So hopefully that was made clear later in the presentation. But yes, when the zips, if you have zip boost enabled, the zips do process general purpose engine work at that point, right? So weights allowing, do zip boost CPs contribute to the hyper dispatch allocation? Zip boost CPs, well, there's no, so zip boost CPs is perhaps a little bit confusing to me. I think the point here is, do you get more vertical high CPs available was the question. No, you're not going to have, from the general purpose engine perspective, zip boost is not magically going to make more weight available for other for the general purpose engines. You may want to consider changing your weights, as we talked about. I hadn't really considered the idea that, well, in the normal case, maybe there's more GP capacity available for the unboosted LPARs, and maybe they want more GP weight during that boost. I suppose that's a possible answer that could be interesting as well. Actually is a very interesting point, because if you gave, I'm thinking out loud on my feet here, but in theory, if you gave those unboosted LPARs more GP weight, you would be restricting the boosted LPARs ability to get to general purpose engines, thereby maybe forcing some more of that general purpose work on the boosted LPARs back to the zips. In other words, forcing the boosted LPARs to rely more on the zip capacity. We would have to see the exact situation to see whether that would make sense, right? And again, in most of these situations, my expectation is that most people are not IPLing during really busy times where this is most interesting, unless of course you're changing your procedures to take advantage of the boost capability to get this stuff done faster. Maybe it makes more sense then that you can IPL. Maybe there's an operational benefit of being able to IPL at more different times during the week instead of always doing it at Sunday morning at 7 a.m. Right? Well, now if the IPL process is such that it's not a significant impact to my operations, and maybe it's even a net benefit in some cases, maybe that means, hey, I can do an IPL at Tuesday at 3 p.m. Right? Maybe that's a good thing. I don't know. I think that's pretty much the questions I had over here. So yes, I realize I'm out of time. I finished 16 seconds late, so that's for me doing excellent.
Well, I was going to say, Scott, I mean, I think we've just got time for a round of applause, because I mean that was really incredible. I'm sorry, the level of insight there. I know this was a 3 chili session, but yeah, no, we really got down to some bare metal there. So very, very grateful for that. Thank you very much indeed, everyone. Please do fill out the feedback forms, because I'm sure you'll agree that was an excellent in-depth presentation. And you can unmute and you can give a round of applause. Thank you so much, Scott.
All righty. Thank you very much, everybody. Do fill out your session evaluation. Again, thank you all for coming. And hopefully, I look forward to maybe seeing you in person in 2022. So thank you all.
Fantastic. Right then. Thanks so much.